Okay, so the video is here, so it's done. I'll send it over to you. It's about 500 meg. So I'll put it on the Google Drive and then you can download it. This was yesterday's lecture. Okay. Sorry. Okay, so yesterday we had a time we're looking at the various kind of languages. We started the SQL language itself. We started with the select aspect, right? So I'm sure now selection and stuff will be easier. Selection will be quite easier now. I've asked Sadika to get some tutorial assignment for you for the week before you meet her on Wednesday. Sadika, what time Wednesday will you meet them? Hello, Cesar. She here?
Yes, Doc, I'm here, please.
What time will you meet them on Wednesday?
Doc, please, can I communicate that on Monday? I mean, tomorrow.
Okay, that's fine. All right. Okay. So Ransford, is Ransford here today? Class rep, are you here? Hey, you people, your class rep is not coming for class. Steven, my class rep, I don't know.
This is not around.
But was he around this morning? Was she at Dr. Matilda's class? Hello, class. Hey,
No,
please.
no, please. He said
we are
he's
not sure if he was here.
no, please. Yesterday I talked to him. He said he's a little bit engaged at the moment. Where he is, there's no network, so he says apologies.
He's inside some village somewhere. Okay. Yeah, okay, so when he's not there, who takes over?
Yeah, we'll do that. Accomplish what?
Please.
Okay, so please get in touch with Sadika, okay? And then arrange the time. Okay. All right. Okay. Put a hi there too. So you can send Sadika a message on the page, right? Privately, then you leave your phone so that she knows that it's your number, then you can communicate, okay? All right. Thanks. All right. Okay, now beyond the SQL one, the selects one, I indicated to you that we have insert, update, and delete. Okay, these are manipulation related commands that we use in SQL. I'm going to focus on these ones. We have a log, call, explain, all these. Now, I must say this. Different databases have different ways they deal with a number of these, like the log, the call, and all of that. What you need to understand is that sometimes these things vary based on the database, right? So if you are dealing with MySQL, it may be different. If you are dealing with SQL Server, it might be a little bit different, right? But things like insert, update, delete, select, these are very standard, okay? Irrespective of SQL language, you always see those ones, okay? Now, when do we use the insert command? We use the insert command when we want to put data into a table. Okay, we want to add data to a table, then we use the insert command. We'll go through it in the W3 schools. Then we have the update. When you have an existing data within a table and you want to modify one or two records in there, we have the delete, where you want to delete something from the table. Yesterday, somebody was asking me about the truncate and then delete. I tried to explain the two clearly. Truncate is more focused on emptying the table, right? Everything that is in a table. all the records that are in the table. Delete normally was go to a specific record, or if you want to delete everything, you have to you try that. That's the nature of delete. It normally is specific a bit more. Now, remember that when we talked about, so look at something here. Earlier on, we talked about acid. If you remember, we talked about the word acid. Atomicity, consistency, isolation, durability. Okay. And then we indicated that only transaction with valid data will be performed on it if the data is corrupt or improper. And then we had the isolation perspective. Now, RDBMSs are very interesting. Okay. Why? Because sometimes to achieve some of the things you want to do, sometimes so let me bring this to perspective. RDBMSs have what we call engines, okay? And we have different types of engines. And most of the times, when you are trying to do a lot of the engines, when you are trying to modify a record, update a record, or delete a record, they try to lock that particular record or sometimes the entire table before finish and then they release. The idea is to ensure there is consistency, okay? So that nothing is violated, okay? But it has its own challenges also. So the locking of tables or table control concurrency sometimes have its own challenges, okay? It can actually also create its own problems. So, and it becomes more evident when the data size gets very big. It gets very big. That's why yesterday I was showing you a table where the indexing, and I'll talk about indexing later, the indexing of the table itself is bigger than the index thing is bigger than the data itself. And I'll explain. We have call and the rest. Those ones are what we use for store procedures and all those things, okay? If you are using Oracle and stuff like that, you have a lot of these kind of call things, right? Good. We have explained plan. We have so many different ones, okay? So now let's take a look at these ones we have here. So I'm going to switch. Next week, when I'm done teaching Hadoop and the rest, we'll try and set up a Hadoop environment, okay? And try to run something HDFS and see. W3 schools. MySQL. Okay, so we did select. We did a select, right? We looked at when you have select and you have where something, right? Then we had the end or not. We talked about order by. Yesterday, we went over that order by. Today, we're looking at insert, update, delete, okay? And I will bring a few of these things. Not all these things cut across everywhere, but I'll bring them. So let's look at insert. Now, this is the basic syntax for insert, irrespective of whether it's MySQL, SQL, or whatever it is. This is the basic syntax, okay? Now you have the insert into, you bring the table name, the columns that you want to enter data for, and then you close it and you have values. So value 1, value 2, value 3. So value 1 corresponds to the record for column 1. Value 2 corresponds to the record for column 2. Value 3 corresponds to the record for column 3. Okay, so that is how it is. However, you can also insert into the table if you know you're going to use all the columns, right? If you're going to pick just a number of the columns, then you do what we are talking about at the top here. Okay, but if you're going to insert it all columns, then you can do this. But even irrespective of that, I prefer this one. I prefer this above just to be sure. Because sometimes you can't be rest assured if somebody has modified the table or you are not the only one working on the table, then you have that. So let's take something like the customers here we have here, okay? The customers thing we have here. All right. So let's pick this particular statement here. So I go to my MySQL. I'm on my querying thing now. I don't have to talk too much about that. Let's open the customers table. This is the customers table as we have it. There are how many records in it? 91 records. We're going to try and insert something. So we place a copy and open this. So I'm bolding it a little bit so that we can see. Okay. So you have that. Insert into customers, customer name. Okay, first of all, let me do this. Let me select star from customers so that we can see it down here so that we are clear. Okay, now I'm coming to do the insertion. So look at the fields. Note something very interesting. We have customer name, contact name, address, city, postal code, country. Then customer name is Cardinal. Contact name is Tom B. Erickson. Address is Skagen 21. City is what? Stavanger. Postal code is 4006. Country is Norway. But it didn't bring customer ID. Have you seen it? It didn't bring customer ID. Now, let me show you something. Let's go to the design of this. When we created this, we made this one here a primary key. Okay. Sorry. We make this a primary key. Okay. However, one of the things is that you can actually decide that, unfortunately, this thing is a varchar, so you cannot it's not an integer. If the customer ID was an integer, then I can have an auto incrementing thing, okay? So that automatically, let me just let me try and bring something here. Maybe ID2. I'm just doing ID2. Okay. ID2, I have it as an integer. Okay, so okay. And then look at something. So if this is an integer, I can say I want to have it auto increment. Okay, if I save this, what is it? That's a day. I'm just going to make this that. I mean, let me see. Cannot drop needed. Okay, there's a foreign key on it. All right. Now, unless I take away the foreign key relationship over there, but you let me leave it for now. Okay. This is customer. Come here. Let me see. Let's go back here. Let me see my relationship I have here. Do I have any okay, something else is referencing it. Customers, others will reference it. Others, I'm sure is referencing that. Okay, we have this here. Oh, okay, it's dependent on it, so let me not bother my head. I have to create a different table and use it. 1 minute. Just guys, 1 minute. Let me create a copy of this table. I've created this now. Let me refresh this. So I have customer new here. So if you take customer new, you have this. However, look at something very interesting here. Okay, if I pick this, because this guy is an integer, right? Automatically is permitting me to have an auto increment here. So I can decide that over here, this thing should auto increment by itself. And then make it also the primary key. Once I do that and I save, it's saved. Now, look at something very interesting here. If I double click this, there's nothing. The records is just as it is. It's empty. But anytime I come here and type maybe, this is Kwedu, Kwesi, maybe blah, 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 maybe Ghana. I'm just making an assumption. And then I save. Guys, what happened? Have you noticed I didn't fill this guy, but it has become 1. Okay?
Yes.
You see that? Good. When I try to do the next, I try to add another record. Okay? Okay, maybe so that, maybe something like this. Maybe China. I'm just making an assumption. And I see. You see, the next one has become 2. Have you seen that? So it is
Yes, please.
auto-incrementing by itself. Okay? It's auto-incrementing by itself. And so if you notice the query here, I just want to explain this query, the way it's being structured. Now, because this customer ID contains, it contains text. So CUST001. I cannot do this guy is a primary key, okay, here, okay? It's like the identifier I'm used in uniquely to identify each record, right? Or each row. Despite that, I cannot do an auto incrementing on this because it contains what? Normal text characters, okay? Or varchar, that's what we call it, varchar. Or it contains that, so I cannot do that. But where I want to do such a thing that automatically is creating its own IDs for the customers, then I will have to have an auto increment and it has to be an integer. So please learn these things. If you're going to do that approach, then you have to have it as an integer. If you go the other route where you are able to, you have something like this one we are seeing here, then you will have to write something which automatically creates this thing when it happens. Are you getting me, guys? You will have to write something which creates this automatically when it happens. Okay? There are ways around it. And normally we do these things using the triggers. Using the triggers. We have what we call triggers. Okay? If you come to, let me come to customers here. From the table perspective, customers in design, you have triggers here. So you come and create a trigger. Now the trigger will, if I say this, I say before. Okay. So before you insert the record, create so and so. So I'll write a small program there, or a small code there, which will automatically do that. Let me give you a practical example here, since we are having this. Okay, so you've all seen 1 minute. Let me stop sharing. I want to be a bit. Sometimes people are funny. So let me just be a bit of this. Just a minute, guys. Okay, great, wonderful. So let me come back. Just a minute. So let me share my screen back. All right. So I wanted to show you how that happens. So if you take something like this, okay, I'm just showing you. I mean, you've all seen, I'm sure most of you have used EMS before. If you have, you see that on the EMS, there is a unique number which constantly gets created. This basically means is moving from Kumasi to Central Post Office, okay? And then the rest of the things that are in there comes in a whole different sequence. Okay. Then you have, this is local EMS, and this is foreign EMS. So this is showing on the international front, there is a way the numbering sequence works. So you have this, and then you have is leaving Ghana. The US people, if it's US, they have a way. There's an international standard for it. Now, why am I pointing to this? I wanted to show you something. Okay, so now let me try and bring this up. Okay, so if I take this one, let me come from here. Okay, so if you take this structure, you see there is an ID, there is something here. The ID is there, all right. This one is auto-incremental, but this is also a unique thing that we're using there for that. Now, I just want to show you, there's a trigger here which says before insert. There's a before insert trigger here. Now, this is the typical example I'm bringing across. So the numbers you saw there created, I had to write a code which tries to do all these things which you were seeing to be able to finally generate a number in this. I mean, there's some checks it has to do and all of that kind of stuff like that before it's able to get the what we call the house airway bill number right out. Now, so similarly, if you're going to do that with the customers we have here, the customers table you have here, you have to write something like that, which at the end of the day will put together the CUST one. You saw that the data had what? CUST 001, CUST 002. You have to find a way you write the code such that it ends up generating this in the manner in which you want. Okay, so if you go this route of this, then you have to learn how to write triggers and all that to be able to create these things for you dynamically. Okay, if you don't want to use triggers, you can also put it in your actual, if you are programming, you can put it in your normal code, right? However, those ones have their own dangers because When you do that and two people are entering at the same time, how do you check consistency? You know, I told you, acidity. How do you check consistency to ensure that this thing is there's no violation on some constraints you placed there, that no two customers should have the same number. Okay. So normally we try to do that on triggers. If you do a trigger, because naturally it's, you know, it's indicated here. Let me bring it up for you to see. In the acidity perspective, one of the central things when it comes to the acidity is, let me see, isolation. Simultaneous will not interfere with each other. All valid, so it queues. So transactions are queued so that one does not interfere with the other. Okay. So you need to think how you want to do something like that. All right, great, wonderful. So those are what we call triggers. You can put them at that point. But if you don't want any of that and you think you want to do something very simple, then you can go the other route, which I talked about, where you do your auto increment nicely, blah, 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 blah. It happens, you work, and it works that way. Okay, that said, okay, I'm not going that this way. I'm not coming to write any. So that said, I can come here, and normally it's because of U3 school. If it was working, I won't come this way. I'll execute it directly there. But now I have to, these ones are my own data I generated. Okay, so now if you do insert into customer so and so, we will have some violation because the customer ID here will not work. However, because the customer ID is not auto-generating itself here. However, if I insert this into the new, the customer's new, this one, the one I generated, let's look at it. Let's look at the records in that database, in that table. So I have these two records, right? And anytime you insert, it's automatic. So if I come here and I click on my query and I have this nice query here, and I decide to insert this record, right? Because it's going to customer new, okay. Let me see, customers new, this one. Okay, and then I run. So you realize that the records have been inserted. It's affected rows 1. Now let's come to our customers new and do a refresh. Have you seen that the record is inserted, but this time an ID has been added 3. But when I was running the insert statement, I did not put anything in there. I did not even reference in the columns the customer ID, because the auto increment will automatically bring that ID. Okay. So that is where the difference is. If you're going to customize the way these are, then you have to write your own triggers to do the incrementing here and all those kind of stuff. That's your own business, right? And it's very important. For instance, if you were the person who did the Ghana card and all these things, you need to write something which auto-generates based on some things you've agreed with whichever client that you are working with. Okay, good, beautiful, lovely. Are there any questions, please, before I continue? Any questions? So that is how you deal with so the insertion statements are very simple. You've seen how inserts are, right? Good, beautiful. So that's for insertion. Now, sometimes you may end up having null values. If you notice what I had here, right? When you define the fields, okay, you can indicate that it can accept null values or not. So for instance, this particular one I have here, customer name cannot be null. Okay, customer name cannot be null because we've checked it and said that customer name cannot be null. So if you don't want a specific column to accept now means it's empty, right? It's like that. So so for instance, right now, if let me modify this thing here, and then I decide that I'm inserting this record, I'm not filling customer name. I'm filling all the others. Let's see what happens. So I run. You see, it's giving me an error. Filled customer name doesn't have a default value. So because of that, it is trying to reject, okay? Because it's expecting a value in that customer name. So that is how you deal with null values, okay? So null values, so some columns you can say, this one, I don't accept anything empty. Something must at all costs be in there, right? You can even define the specific range of values that should go in there. All those are what we call, they are constraints, but I'm not going into those ones now. Okay, good. Let's go. So that is it. Now, there are so many ways that you can go about this, okay? So for instance, and then you can also use null values in your select statement, okay? What you're trying to do here in your select statement. Let's say that what we had here, let's bring this, let me call this menu. Let me put here menu, but this guy will be null. So contact name is null. Let me make this 25. Let me make this Accra or something, right? Let me make this Ghana. Okay, and I run this. Where's my error? Okay, good. Okay, so it's inserted. Now, if you take a look at the data here, if I refresh this, you realize that the contact name here is now. And so I can write my select statement and say, select star from customer's new, where contact name is now. Okay, so this is how we write it. It's now. When I run this, it will bring me only the menu record because that's where contact name is now. Okay, good. Please. Now it's not the same as sometimes you can put an empty thing there. It doesn't mean that it is not. Now I don't know how to put it like now it's like, let me use this analogy. You've heard of the word vacuum, right? Vacuum is not the same as emptiness. Okay? The room is empty doesn't mean the room is vacuum. There's vacuum in the room. There is still air. There is still air in the room. So you can't say the room is the room is I don't know how to use it, but that's in science, that's how we put it, right? That means there is nothing, 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 including air. But I can actually say blah blah blah, say maybe I want to insert something. I said it should be equal to this. Okay. You see, when I did this, it didn't bring me any results because it's not the same as now. But there's nothing here, right? There is by the physical eye, there's nothing here, but in coding, this is very different from now. Okay, right, good. So I wanted to draw the difference so that you understand. Okay. So that is how you work with now. If you don't want to not now, I mean, you've done the not, so you understand that one. Okay, so that is for inserting, right? For inserting. There are several ways to do insertion anyway, but this is the most common and the easiest way by which we do that. Then the next data manipulation one is MySQL, is update. Now, insertion does not require a conditionality. Okay, note it. in the insert statement, there is nothing like a condition to insert. Okay, if you look at the syntax, there's nothing like a condition. But if you take select, for instance, let me use the where. The where if you do where, then we are looking for a condition. Okay, the same vein. Saka, star means every column. Yesterday we talked about that. If you want to return everything in the column, you have this. If you specify the exact column names, then you have that. But if you use star, that means that all the columns. Okay. Please visit the W3 schools. That's why I'm using the W3 so that you can go over. So that in my absence, you can still be able to do that. Even if Sadika has not had tutorials with you, you should be able to still go over and check to see. So please, before you meet her for tutorials, try to have gone over some of the things so that if there are issues, you can ask when you meet her, okay? All right. So the same thing when it comes to updating, we normally expect a condition to happen, okay? So look at this. Update the table name. That's the syntax. Update table name. Set a particular column to a particular value. You can have multiple columns and their values. Where so and so. You cannot write this thing without the condition. That is why I indicated that when it tries to update, it sometimes tries to lock the records because somebody is updating. You want the one who is coming first to finish updating before you can bring yours. Okay. But most of the time, these things happen very fast. So most of us, we don't see it. But the last person whose update statement happens is the one whose records will finally be seen because it would have modified the old one into a new one. Okay, good. Beautiful. So if you take this particular data here, you have 1, 2, 3 here. You have update customer, set contact name where customer ID equals 1. Let's try it. Let's go to our Navicat. So in this case, I've told you we are using the auto increment. So if we are using the auto increment, then we'll say update customers, blah, blah, where customer ID is maybe 1. If you want to use this, that one is customer new, right? That is customers new. Okay, good. So I'm going to try that one. So I'm updating the first record, which has 1. I want to change the Kwadwo to Nancy Nkrumah. Is it Kwadwo? Antenna is Kwesi. The contact name is Kwesi. So I want to update this record and say that I change the contact name to Nancy Nkrumah. Okay. The city may be Kumasi. Let me just do that. So once I run this, I've run it. It has updated. So you see affected rows equals that, right? When I refresh this, you've refreshed down here, you see Kwadwo, you see Nancy Nkrumah, you see Kumasi. So it has updated it. So there is always a conditionality to that. For instance, if I wanted to do that for just the customers one, the customers one has the CUST, blah, blah, blah. So let's say Oforiwa Limited. I want to update this one. So customers, so note something, because the other one was integer, we're just using the raw number. But because this one is it's a varchar, I'll have to put it into, how do you call that? Is it parentheses, whatever, right? That one. Okay, so you put it in it. Okay, update customers, contact name equals so and so. Maybe Nancy Nkrumah Limited, right? Nancy Nkrumah Limited. Let's make here Koforidia. So when I run this, it's updated. Now, if I go to the normal customers table, which is, you see the fourth one, which we're trying to look at. Now, let me do a refresh on this. When we do, you see that Nancy Nkrumah Limited is here. Koforidia has also been brought in. So that is how the update statements work, okay? Update always comes with a conditionality. All this is geared towards, that's what we call them data manipulation. You are manipulating the data. Okay, you are manipulating the data. Are we all right on this? Now, if you don't bring the condition at the end, I'm coming to do one, which is very dangerous, but I will do. Okay. If you don't bring the condition at the end, let's try this. If you don't bring a where at the end and you fire it this way, let me use the country. That one I can easily reverse. You realize that in customers, all the country are Ghana. Okay, I want to change all the country to Nigeria. Update so and so, right? Customers, country. Okay. Because I've not put any condition, it will update every record in there. So if we come to customers table, everything here is Ghana, right? I think did I do, okay. Everything here is Ghana. Then I fire this. So you realize 91 records have been affected. Because I didn't put any condition there, it will just update everything. So please be careful when you don't bring conditions and you are running updates. Remember, you mess up, your whole data will mess up. That's sweaty too. You'll be shocked. So please be careful with your update statements. Your update statements. Your update statements. Your update statements. Very, 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 very important. Okay? Be very careful with them. Because of that, in some languages, what sometimes they do is that when you execute it, they will ask you either you want to commit it or you don't want to commit. If you don't commit, that means it's like undo, you can undo. Okay? But if you commit it, means you can't come back and say that you made a mistake. So this is very, very important. All right. So we've done the updates. Now let's deal with the delete. Any questions with the updates, please? If you have questions, please ask. Hey, Mom, was that question here?
Doc, please question.
Yeah, Sani.
How do you update more than just a single row?
Okay, beautiful, lovely. So it is all about the condition. It's all about the condition. So let's take, for instance, this data here. I'm using this. Okay. It is the so in this particular, I want to update 3 and 4, record 3 and 4. Means that, what is it? I can either say I want to update, because these two are the same. I can either say I want to update where postal code is 44006, and that will update both records. Do you understand me?
Yes.
Other than that, I can come here and say, let me do an undo here. Just a minute. Come back to this. Okay, good. Update contact name. Set so and so equals that. Let me make this rather Efia Mansa, who is from Tamale. Okay. Now, instead of this, I can say, okay, I want to update every record which has an ID above 2. So I can say where customer ID is greater than what? 2. Are you getting me? Sani,
Yes.
Are you here with me?
Yes, please.
Good. Once I run this, if I come to customer new and I do a refresh, both records have been updated. Have you seen that?
Yes.
So you are the one to state the condition. If you want to, if you think that you're going to do them 1, 1, 1, 1 and stuff like that, then you have to come here and say this one, update this to let me say Sewa Let me have you as Kumasi. I'll copy. You always use a semicolon to distinguish one update statement from the other. Okay. So maybe this one will be 1. This one will be 2. This one will be maybe 4, right? This one is AC. This one is maybe Cape Coast. This is where's the Ama. This is Accra. So when you have this in this way, it will execute one after the other. So look at it. All 3 have been executed. Are you getting me? Are you with
Yes.
me? So normally what we'll do is, let me use another approach. Normally what we'll do is that we will open a notepad. Just like how yesterday when we did the ChatGPT. Okay, I'll open a notepad and I'll save this. Save as, I'll copy paste here, save as maybe update customers. .SQL. So I'm creating a file. Let me just bring it here so that it becomes easy to create. So I've done this. So you see that now I have this here. So if I come here, let me modify here. So let's go back to, this is customers new. I refresh. The various updates have been done here. Now I want to be able to execute this in a bulk, right? So I come here, and that's, in fact, I like the question you put. That's what most of the time you end up doing. Maybe this is Adjoa Kwame Kweku. Okay, so I save this. Okay. Then what you normally would do is you come to the thing here, you right click and said exit, and you say you right click on the table, right? Or whichever one you want to. You click on tables. On the other side, you right click and say execute SQL file. Then you browse. Then you go to the file itself. Then you say start. So you see it has executed the whole SQL file. Are you getting me? Sani?
Yes, please.
So I've run the whole thing. It has done the update. So you see, this one was very fast. It didn't even open it to tell me what was in there, the one I did right now. So normally, if you have so many statements, you put them in an SQL file. That is why the day I was trying to create the tables, I tried to put everything together so that I can do that. If you don't want that to, you can you see. Okay, you can also open directly, like what I've done. You come Control A, copy everything and come and paste. And then you can run. Okay, that thing was changed. It's the same record that is there, so nothing was changed. That's why it's affected rows equals 0, because no record was modified. It's the same old statement. Okay, good, wonderful. So are you okay with that question? Any other question, please? Yeah, go ahead.
So this for assessment purposes. So let's say in exams, I know we have MySQL and we also have SQL Server, all with the base of SQL. And there's a little bit of differences within their syntax, just a little bit. So let's say in the final exams, if you are asking us to write, let's say a SQL statement, should we stick to MySQL syntax, or we can write any SQL statement that makes sense?
If I'm specific, it's MySQL, then you have to be more specific, right? But normally in exam, I'm not so keen on there's so much. I won't ask you statements which will bring out MySQL's peculiarity. I'm being frank about it, because we are actually treating RDBMS as a bigger thing. So I'm treating more of SQL, but I cannot teach SQL if I don't use an actual database. Do you understand me?
Yes, I do, sir.
In the same vein, when we get to NoSQL, I'm going to use MongoDB.
Okay.
I mean, if I
Okay.
use there are 4 different types of categories of NoSQL databases. MongoDB is not the same as the other. Okay, it's not the same as your typical. Let's take for instance 1 minute here, just a minute. So if we get to the databases, please, 1 minute, I'm coming. So if you look at Mongo is a document store, a type of category of NoSQL database, right? Okay, just like CowDB. But if let's say I want to look at Amazon's Dynamo or Redis is common, right? Then it's a key value store database, okay? And that one is very different. NoSQL is very specific in terms of its nature, okay? But compared to for RDBMS SQL, it cuts across, it's similar. So in exam, I will not be so keen on that, especially with RDBMS. I'm not looking for. If I want to ask you a question, which will bring that out, honestly, I must be fair with you, frank with you. Okay.
Thank you, sir. Thank you
Yeah.
very much for that.
But if I give you a hands-on work, hello, I've told you my questions come in 2 ways. If I give you a hands-on work, then the database will be relevant because it means that you are using MySQL. I mean, you because at the end of the day, you can't execute that query if it's a SQL Server strict related syntax. Are you getting my point?
Yes, sir.
Good. Thank you very much. Any other questions before I move? Okay. God bless you. All right, so we've done the update. Let's do the delete, and I think we should be fine. Those of you who are eager to see the delete. Salter, go ahead.
Doc, please, is it when you did this the updating rules, you did where ID is greater than 2.
Yes.
That one
Customer
I
ID.
understand because the unique identifier is an integer. But what about a situation where maybe the unique identifier is not a number?
So in that case, you have to update it one by one.
Okay.
That's the easiest. There is another approach, but you have to be advanced a little bit.
Okay.
Okay,
Right,
so we
you.
have what we call, you are getting me into areas I don't want to get to, but you let me go. Okay. Let me see whether I can get regular expressions. Wonder. See whether I'll get regular. Okay, good. Okay, so we have what we call regular expressions. Okay. I mean, if you want to get sophisticated, you can do that. So I can write a pattern like what you see here. Are you seeing that? Hello, Olga. The person who asked the question, are you here? Can you guys hear me?
Yes.
Okay, Sota. So if you want to explore that, we have regular expressions. I mean, all languages have it, whether they are database or programming, whatever. They all have it. So you can use the regular expression as a pattern. Okay? As a pattern. So search within my database where you have this kind of pattern. Okay? But that one is you and you have to think through and see how your pattern is in terms of. So if you notice the one we have CUST 00 something, right? 1. So you have to write a regular expression that mimics what you want to do. But regular expressions take time. That's why I said I don't want to go there right now. But if you are interested, this is Jig for Jigs. There are so many sites that deal with regular expressions. Okay. Regular expressions are good. Even for you as an analytics person, it's good because sometimes you may get data, you want to look for patterns within the data, and regular expressions will help you. Okay. So Salt, are you okay?
Yes, sir.
All right. So if you want to do that, you go down route. All right. Okay, so deletion I told you also comes with a condition, okay? It also comes with a condition. Okay. If you write delete from the table straight away, then everything will delete, okay, in the table without deleting the table. But I've told you this is not the best. I always prefer the truncate. Truncate is specialized for this type of job, so it's very fast. Once you do a truncation is very fast. This one, when it's trying to do, check every integrity, everything, so many things. Okay. All right, great, wonderful. Any questions with that? So delete comes this way, right? So let's say that I have this, can say delete, so and so. Delete from customer university equals that. I ran. So I was able to get only one record to delete. So now if we go to customers new, okay, if I refresh this, one of the records is gone, right? The one which had the city as Kumasi is gone. Okay. So that is how the deletion aspect works, okay? Okay. Then the last one is, Christiana, go ahead.
Please say.
Yeah.
I realized when we were updating, you use the primary key to make reference, but when you were deleting, it's like you use the whole you use the column with what you want to specify. Is it that always you have to there are places where you have to use is it a primary key and where you need to specify specific columns?
No.
I don't know
The
if
condition
you understand what
to
I'm trying to
delete,
get.
the condition to delete a record, select a record, update a record depends on you. You know what records in the table you want to update, delete, or select. You will have to decide on it. It has nothing got to do with primary key and the rest, but this is where indexing comes in. So let me come to that place. You are pushing me towards there. I will arrive for you. This is where indexing becomes so you have MySQL create index. Now, we create indexes. Let me show you here. You are taking me a bit more far. Okay. Let me come to this thing here. I want to use a real database so that you appreciate it. Okay. So you see this table here. How many columns are in this table? The number of fields. Do you see it? How many columns? There are 99
8
columns. 99 columns. Anytime I query this data, and I've not indexed the things that I'm looking out for. So normally your indexing comes from your where statement. The condition that follows determine the way you do your indexing. Why do we do that? Because that is the basis for maybe deleting, the basis for me selecting records, right? And because of that, I want to index that. When it happens that way, the database will create in the database, it creates an index table sort of, right? Identifying all these records with this particular conditional statement, the where part. Let me come here. Okay, so in this particular one you are seeing here, these are the indexes we've created on the table. So I have an index on the house airway bill number. So anytime I write, even if it's 100 million records, and I write a statement, select so and so where maybe HAWB equals this. Results in paper fast. Pa. The moment I write, you come. Pa. Do you know why? Because it doesn't even go into the table itself to bring me the records. It goes to the index table and quickly identifies where HAWB is this. Then it goes to fetch it and bring it. Fast. So normally we use indexing when we want speed. And it's the more reason why NoSQL databases came, because when data becomes very big, sometimes the index, you've seen this particular table, the index is bigger. Look at the index. This is the size of this table. The data itself is 1.18 gig. Can you guys see it? 1.18 gig.
Yes.
Yes, sir.
A data consisting of 99 columns. 99 columns have a size of 1.18 gig. However, the index alone, the index which follows just these few things here, is 1.86 gig, which is even bigger than the data which has been collected. Do you understand me? It's because if you don't do the indexing and you run a query, Sadika is here, I'm sure she will tell you. Or anybody, Stephen is also here, you can ask anybody who has worked with data. When you work with data, when data becomes big, you have no idea, it's a headache. I want to say, same thing with data, that's why we have database administrators. That's why we have people who deal with database. Because you have to build capacity and speciality towards it. Okay, so these are very, 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 very important. So if I take, let me show you the cardinal. So you see here, it's showing cardinality. Look at this. When I click on each one of them, there is a cardinality number here. What it simply means that whenever a statement is typed with the where statement, where type of product equals this, and item area equals this, and user ID equals this, that thing uniquely within the entire database, there are 4,342 of them. So it has kept each of them in a certain way in the index table. So when you fire a particular one, it quickly looks into the index table and say these records, based on the primary key, these records are the ones that you need. Bim, it fetches them and brings them. So when you fire within 5 seconds, though it's millions of records, quickly you have your data. Okay, this is about this is 1.8 million records, right? And this is just 2 years of the data. Normally I would leave just 2 years archive. Is it 18 months or 2 years? One of them. Sure. Okay, good, beautiful, love. So you have that, right? So this is what makes, so my dear, the where statement is important, But it's not important because of your deletion and the rest. It's important you because of speed. So because of that, you index based on the way you have been doing your where statement. If I'm writing a software, I will look at all my where statements and the way I go about them. Okay. And on that basis, the ones which are very necessary, I create an index for them so that the system can quickly bring those data quickly out when I need them. Are you okay? Saka, Christiana, are you okay?
Yes, sir. I'm okay now. Thank you.
Good. All right. Who are the UITS people here? UITS, are you guys? Are you ITS guys here? The UITS guys. Which one of them is here? Josh.
Yes, sir.
I mean, you experience
sir.
this every day, right?
Yes.
If you don't index and you run a query, what happens? It takes forever.
Yes.
You execute and you sit down 5-10 minutes, now results not prime peer. You know, sometimes when I hear people talk, sometimes I just say, sometimes you have to you have to enter the mill to understand some of these things I'm talking about. You have to experience it, to feel it, to appreciate it and understand this thing I'm talking about. So I mean, sometimes you recommend to a company, you need a database administrator, but the guy who is programming can do the same thing. Look, it's a lot of work. That's why sometimes, but in Africa, like we were all talking about yesterday, when you start off, you have to create the environment yourself. If you don't create it and let people, bring people to understand, everybody talks the way they talk as if they're on radio stations. But this is the reality. So can you imagine, you guys, when you are logging into the AIMS app, you click now, then it comes. You click on it, it comes. Look at them, so many records, yet they quickly fetch yours and bring yours. It's because they've done some indexing somewhere to make it easy to locate you in the haystack of data. Okay, Christiana, are we fine?
Yes, I'm very, very fine.
Thank you. God bless you. All right. So 1 minute. Let me get back. Okay, so we've dealt with the delete statements. So the deletes are similar. So I was trying to show you indexes, but you took me to indexes by force. So I've gone there by force to show you how indexing is. We'll look at the syntax soon. All right, so delete, blah, blah, blah. So for instance, this one like this, delete from customers, where customer name. If you had about 10 million records and you wrote this statement and you have not indexed based on customer name, hey, as you fire, the thing will take forever to execute. Because, do you know why? And Christiana, you asked that question. Because it has to go through one by one, all the 10 million records, looking for each one of them if they are Alfred, so and so, and delete them. So if there are 3 million of such records, he doesn't even know where they are. He's now going through them. But when you index, he knows where they are. The moment you index, he knows where they are. Therefore, when you fire, he goes to the index to go and look for where these things are. Okay? All right. Great. Wonderful. Okay. Okay. Call and the rest, I'm not going to focus much on that. If you're going to do that, but those who are curious, if you are curious about them, then you have to deal with them. Let me see whether in this one they have something around it. These are built-in functions. Let me see. Okay, I don't see them here, but okay, so you can come and type MySQL stored procedure. Just type this, you get a number of sites. Okay, yeah. W3 Schools has a special for okay, SQL store, you call it SQL. So you can create what we call stored procedures, okay? Stored procedures and then use them, okay, for some of those ones, okay? So stored procedures is like, it's actually like as if you are programming. But if you're doing MySQL, MySQL's own, no, MySQL will come, let me use cursors. So normally MySQL has cursor. Uses cursors. W2 Schools doesn't seem to have cursors there. So a cursor, blah, 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 in a stored program such as procedures and functions and stuff like that. So that's how we use cursors and stuff to be able to do that. Normally we put them in a procedure. So this is a typical MySQL type, okay? Where we declare, it's actually like coding, it's actually coding. So the one that you saw, the one I had a trigger, you write your triggers similar. And once you are done, you use the call, then you call the procedure, okay? Right. So that's how the call thing that you see there works, okay? All right, great. Okay, that said, let's look at a few other things. Let me see. No, I think let me deal with this ones. Okay. Okay, let me deal with these and then bring a few things still within the manipulation place. Then we have data control languages, okay? Now, after you have built your database and the rest, there are permissions you give to different people, what they can do, what they cannot do, what they can access, what they can't access, all those things, okay? So to do that, normally we use what we call, you say you are granting permissions, okay? And so the word we use is grant, okay? Grant and revoke and all of that kind of stuff. Like revoke means that you are withdrawing the user's privileges. So you can use that to restrict who is able to log in. Even if they log in, what can they do? Can they only view certain records? Can they only view certain records? Okay. Can they only view certain records, right? Very, very important. Okay, so those are some of the things you look at, okay, right? Okay. So I think I've covered largely. Then there's the commit and the rollback ones, right? That's the transactional control languages. Okay, so I have a table here which shows a number of them, right? And stuff like that. Now let's look at a few of the TCLs, the transaction control ones, right? A few of those ones. Let me come with them. Okay, so let's start from, okay, so we did create, drop, all these things, all okay. Now let's go to constraints. Now, so in my SQL or in SQL General, we have what we call constraints, okay? Now you can create constraints on a particular table, okay? The essence is that you want to have specified rules for the data that people insert into the thing, or even if they are modifying it and stuff like that, okay? So that aspect, okay, leads to some level of controls, okay? So normally most of these things will fall a bit into that sphere, right? So we have unique, primary key, foreign key, check, default, create index. Okay, good. Now, if I take not now, we've talked about not now already. So when you are defining it, if you are going to write it in a statement, for instance, you have your ID, the data type, and then you say not now. So if you don't want it to be now, you put the not now, not now. I showed you in the interface one, that was easier. But then you can also do it here. So when you are defining, when you are creating your table, you put those constraints in there. Okay, good. So that is not now. If you want to modify it or alter, you say alter table, then modify, blah, 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 not now. So in this case, it was now, but now you want to modify into that. Good. Then we have unique. Uniqueness means that the record is very, that record is, there are no two of them. However, please, being unique doesn't mean that automatically that thing is a primary key. No. Okay, I'm going to show you a practical experience of it. If we take the database I'm just showing you here, in here, HAWB can be unique, but it's not we didn't make it a primary key. We have the ID being the primary key, but HAWB can be unique, okay? Because we try to identify it, there are no two of them, right? Good. So if you look at the indexes we've created here, HAWB is one of them, created nicely here, okay? And we've indexed it as, so we try to create uniqueness. Uniqueness does not mean that they are primary keys, okay? Okay, so very important. So if you want to do that, you say unique and then, and please, these things, the ones you create as unique, primary key, foreign key, they all come at the tail end, okay, after you've written everything, you bring it at the end here. So you have something like this here, okay? But all primary keys are unique, right? But not all unique keys are primary keys, okay? There can be only one primary key. So even if in the record, uniqueness can exist for many columns, there can be only one primary key in the entire thing, okay? Good. So if you take this, create table, this is the unique, he's made the ID unique. If you take something like this, he's creating a uniqueness between the ID and then, so you can actually join two fields or two columns to create a uniqueness. Okay, you can do that. You can join two columns to create a uniqueness. Okay, so this is the syntax. You write blah 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 constraint. You give it a name, unique, and then you specify the columns which come together to create the uniqueness. Okay, this is when you are altering it and stuff. So, I mean, when you want to drop it, alter tables. So when you drop, you can drop the index. Okay, so this is but in fact they're actually indexes. So I've told you when you create the unit, they're actually indexes. Okay, that's why if you notice here, alter table, drop index, so and so, because it's an index actually. Then we have primary key. Primary key is also one of those, right? So to define a primary key is the same way like the unique. So you've done everything at the tail end, you say this is your primary key. You bring the column in there, right? Good. If you want to join, you can also form a primary key between two different columns. All right, two different columns. So you can also do that if you want to do it that way. There are a number of databases I know which work that way. Okay. Everyone has its advantage and disadvantage, so it's up to you. Okay. Then we also have foreign key. Yesterday we talked about the foreign key. Okay. Now the reason why we create a foreign key is that there is a parent and a child. We don't want you to go and affect the child's record if the parent exists. Okay? We don't want you to go and, because the parent is to protect the child. Okay? So it is used to prevent actions that would destroy the linkage between two tables, primarily a parent table and a child table, right? Normal. Okay. So we normally use foreign keys at like. Then normally foreign keys will refer to a particular primary key or unique key. Let me be clear here. A particular primary key or unique key. It's not always it's a primary key or a unique key, okay? So that's very important, okay? So the foreign key, where the foreign key exists is the child. And where the primary key exists is the parent, okay? So if you take something, let's take these two tables, persons and others. Here, this is the persons table. This is the others table. But if you look in the others table, we are linking the customer or the person here to the very other ID here. So to be able to create a relationship between this, a foreign key relationship between this, the primary key table is the person's table. That's the 1, 2, 3, blah, 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 blah. Then the child, this is the child based on the person ID here. So the child is here, right? Good. And you link this to this. So you have person ID related to this person ID here. Okay, great, wonderful. So if you are creating it, this is it. The primary key is this guy, but the foreign key is what? Person ID, references, persons, person ID. Remember, you create the foreign key in the child, okay? You don't go and create the foreign key in the parent table. You create it in the child table because that's where you seek to protect the child, okay? Good. Very, very important, okay? So we have that. All right, wonderful, wonderful. Oh, these are the authoring and stuff. You can take a look, a closer look. Okay, now that I've done this, let me come into the interface. You can also do this using the interface. You can also do this using the interface. Let me come to the interface part. Let me shut this guy down. If you take this, okay, other details here, I'm sure it has a foreign key in there. Okay, good, beautiful. So I can actually create, let me look for one which is very simple. You have products and you have, let me see. To be primary. So we have others. Good. So if you take this, there's a relationship between the shipper and this one. So I'm going to do this. If you are using the interface, I'm coming to have shipper ID and that, okay? Okay, great. So I want to add a new foreign key. Let me save this. I want to add a new foreign key. So I come here. You can leave it blank or you can actually put this. If you don't put it, automatically MySQL, Navicat through MySQL will create one for you. Then here, you specify the primary key. What is the primary key in this table? In other words, the others table that you want to reference in the other one, okay? You say shipper ID. So I'm trying to have shipper ID, which is a unique, I'm seeing it from that perspective. Referencing table what? Shippers. And in table shippers, what specific column is it referencing? It's referencing shipper ID. Now, what you want to do at this point, and this is what we do. So if you don't want anybody to delete anything, you say you want to have you want to restrict it. That means that if somebody tries to delete something here and it's going to create problems in the other one, then he'll prevent you from doing that. Means that if I want to delete the records that are in the shippers table, I will have to delete all the places where the records which have shipper ID in them in the other table. So the two tables are linked. Okay, so on delete restrict, that means I don't want anything to happen. Okay, but if you put cascade, that means that what you do here automatically let it go and reflect in the other one. Okay, so if a parent is taking off, then the children will go off. Okay, all right. So these are very, very important. Okay, great. So here I've created that using the interface. You can use the writing or the interface, whichever one. And these are very important. Okay, you have an exercise on it because these form the basis for your ER entity relationship diagram. Okay, wonderful. So that's a foreign key, primary key. Any questions on foreign key, primary key? Any questions, please? Any questions? Yes, Christiana, go ahead.
Please, my question is on the unique is it your unique keys.
Yeah.
When you have a primary key and you have a unique, you made two different things, but
I
can
said
you
that
use a unique?
I said that all primary keys are unique,
Are
are
unique.
unique keys. But not all
But
unique
not
keys
all
are primary
unique keys
keys.
are primary keys. Good.
Do you understand
So
it?
can you use? Yes, I understand it very well.
Only one
Can
of
you
your
use?
unique, I'm coming. Only one of your unique keys can be made a primary key in the table.
Okay. And
Go
I
ahead.
understand you can join two. You can join two columns.
Yes, to form a uniqueness.
Yeah.
In the
Yes.
same vein, you can join two columns to form a primary key because all unique keys, I said, can be primary keys, but not all primary keys are. Do you understand? Not the other way around.
Yeah, confused. But I understand, but
Okay.
that means when you
Okay.
want to pull out
Relax.
a data,
Relax.
so can I ask
All
my question?
ask your question.
That means can you use the unique key, whether combined or single, to pull out information fast from a large data? That's
Of
what I want
course,
to.
yes, because it's an index. All primary keys have been indexed, right? Naturally, all primary keys are automatically indexed. The same way, when you create a unique key, it automatically becomes an index. Because the system has to uniquely identify each one of them and keep it somewhere. That's why you are calling it a primary key. So when you fire, it quickly knows where it is in the table and bring it to you. Even you have millions of records, you fetch it quickly and bring it to you.
So say, if
Yeah.
I understand, the main purpose of these unique keys and the primary keys are to get information faster for you from a large database,
Yes.
right?
There are two things. They
Okay.
serve as ensuring integrity in the data. That's the one. Because when there is uniqueness, you can say that this thing, if something gets lost, you know this is missing, that is missing, right? Right?
Yeah.
Or like you're in a class right now. I want to uniquely identify, your name is Christiana Saka, right? Okay. Assuming there's another Christiana Saka in the class. I need to be able to identify the two of you uniquely, is that not it?
Yeah.
So some lecturers will say Saka 1, Saka 2, is that not it?
Yes, sir.
Because I need to find a way to uniquely identify you. So that uniqueness perspective ensures the integrity of the class, that I can say that this and this are unique, this and this are different from each other. Do you understand my point?
Yes, sir.
So that is one. The second thing, so the integrity is important. The second thing is what you mentioned. When the data becomes very big, when you are in a class of 5 people, the potential that the same people will have the same name is less. Is that not it?
Yeah.
It's very, very less. It's very minimal to have two people having the same name. But Christiana, you can't tell me that your
Yes,
name in KUSC may have it. Let me tell you, this is just by the way, let me tell you a story. It's not a story, it's a real thing that happened. One of the people I know, they went to Legon, right? And amazingly, when they went to Legon, he met somebody. And the guy really, and the person really looked like him and his siblings. The guy really looked like him and his siblings. And the surname was just like their surname. Everything was so unique. But it's like, but this guy is in Legon in university, 20-something years. So he approached the person and became friends. And then tried to ask, who is your father? Amazingly, they say they have the same father. So somebody say family trafficking coming. Amazingly, they were siblings. They never knew each other. So their father was in the house. When one day they vacated and they came with the assembly to the house. So in a bigger population, that's where I'm going. In a bigger population, the potential for that is very high. Do you understand my point? I mean, it hardly occurs, but it's possible. It's highly possible, right? So that is why indexing and all that is critical. That's why we are doing fundamentals of big data. When the data gets big, like I'm telling you, you need to find strategy. In fact, can you imagine when Google and the rest, this was a problem they were faced with. Look, how many you alone, you generate over, today, I wonder how many WhatsApp messages you have sent or how many things you've typed. I'm sure in a week, you generate huge volumes of data. And they need to keep track of all this data. So that was their problem they were faced with. So they had to index. At a point, the thing cannot even be indexed because the index is too big. That's why the data I showed you, every say 18 months or 2 years, we cut the data off. So we always cut off. We always cut off. Most banks do it. Everybody does it. So we send the data into an archive state. If you want it, you go into the archives. Because if you keep on, Charlie, I mean, the data you saw basically is handling every parcel going outside the country, coming in, local parcels, moving, local EMS moving up and down, everything going on. Can you imagine the millions of records that gets generated every year out of this? And you don't have a choice. You still have to run the system. So that is why, my dear, uniqueness is important. That is why indexing is important, okay? So primary key, there can be 10 unique keys in a table. Uniqueness means that each one of them is different from the other, right? In terms of record, one. However, you can only select one of your unique keys as your primary keys. But you can also form a primary key by joining two columns. But at the end of the day, if you join them, at any time, that two must be unique when it's called upon. Because sometimes you come across tables where you can't form uniqueness based on a single value. Because of that, sometimes we combine two columns to create that uniqueness that we need, so we can have it as a primary key. Okay. Saka, are you okay? The person who asked the question, are you okay?
Please, I'm 100% okay. Thank you.
Thank you. Please practice. There's no secret behind this. Just practice. Just try it. Make the mistakes. When you meet Sadika, you can fed that, because you see, if you don't do them before you meet, you will think you know, but you will not know. Please. Okay. Good. All right. Then we have the check. So the check constraint checks for certain things. So for instance, look at this, right? So if you look at this, the check constraint on the age column where the person's so the check constraint ensures that the age of a person must be 18 or older. So if you write in creating the table, you put a check age is greater than or equal to 18. That means that in this table, there can never be an age less than what? 18. It's a violation. It won't work. Are you with me, guys?
Yes, Doc.
Yes, Doc.
So those are what we call the check constraints, okay? All right. Then we have the default constraint. The default basically, what it does is this. When you say a particular, you define a particular column and you say default, so and so, it means that when a record is created or a record is inserted, let me use it that way. When a record is inserted and no value is entered, you remember the other one, the null thing which we tried to select when we didn't type anything, right? But if you have a default value, if nothing is entered there, automatically the default value is entered. Is what is recorded. Okay? And these are very important. Why? Let me give a typical example. Okay, you are doing a system, and the system is to ensure is for the majority of the people on the system are Ghanaians. Okay, and then as you insert the records, let me take you are inserting the records. As you insert the records, you want to have the country being default Ghana. If they don't enter Ghana, if they don't enter any nationality, you want it to automatically say that person is from Ghana. So you put default Ghana. So that anytime that happens, Ghana is placed there at the person's place. Okay, good. All right. You can use some of these things like the check constraint, for instance, to check and make sure that every data being entered into a particular, if it's sex, male and female, male is either male or female. Any other value you don't accept, the system will say there's a violation. Okay. You can have default being, if it's a date, you can say the default should be the current date. So at any time the T, let's say it's an invoice, it's an invoice thing. So you can have the default invoice being what? Being today's date. Okay, great. This is how you drop them, alter, and I don't have for the alter and those ones, I won't talk again because I think you've been seeing them. It's a constant way of dealing with them. Then we have the index. So those of you who are interested in indexing. So when you're creating an index, you say the syntax is create index, the index name on the table, and then the specific columns. Okay. You can create a unique index. Unique index ensures that, and please, you can't just create unique indexes if you are not sure the data will not contain duplicates. If it's going to bring duplicates, then just create an index. That's all. I mean, normally I prefer creating just an index. I normally don't even bother myself with unique index because if it's a unique thing, it will show itself. I don't have to, so I just go create index. Okay, good. So this is a typical example of it. Okay, create index so and so on person's last name, create index so and so, right? Good. Auto increment, we talked about auto increment earlier on, but let's look at the code. So if there's the syntax, you have person ID and then auto increment. Please note, if you're going to do auto increment, it has to be what? An integer. Okay, guys? It has to be what? An integer. Okay? Because we are dealing with numbers and it should be not now. All right, so you have this. You can also set anytime, if you notice the auto increment, what it does is, let me go to the real data so you appreciate it, how auto increment works. So if we take customers new, let's go to the design of this. Okay. Now, when I come to options, let me go to options. Oh, sorry. This is an old one. So let me bring it up back again, okay, from the object point. Look, the next auto increment value is 5. Because if you come here and you look at customer new, the last ID is what? Customer ID is what? What's the last customer ID?
4.
4. So the next auto increment value will be what?
5.
Good. So it keeps track of all these. That's what it does. Now, sometimes you might want to force the next auto increment value. You want to do that, you come and say, alter the table name, auto increment, then you put the value there. So if I do this right now, let me just do this. Let me come with here. Then I run this. Now, because I have done this, let me just come back again here. I go to design, I go to my options. What is the next auto increment value?
100.
Yes. So now if I come and I run that insert statement, do you remember that? So if I run this, let me run this. If I run this, I get this. 1 minute, customer new, and I refresh. Have you seen the next ID was 100, not 5?
Yes.
Because I forced the auto increment value. So you can do some of these things. I mean, sometimes you just need to think outside the box and see how you use them. Okay, we are almost at the top of the hour for our break. I think I've covered most of it. When we come back, I'll cover, as for dates, you can take a look at dates on your own. Okay. Views are important. Okay, I'll talk about views. Views are very important for the data, for the analytics work you do. Views are important. What else again? Okay, then we'll talk about a bit of inner join and a few of these things, okay? Then we'll take it from there. Next week, we will focus on the, then later on, we'll focus next week more on the terminologies and all these things, right? We'll focus on the big data terminology. So we start entering into the fact that, so we would have done with the normal traditional databases, which is the RDBMS, and its constraints, which you are seeing when the data becomes very big, right? So then we'll move gradually into why Hadoop is important. We'll try and set Hadoop on our machines ourselves and see how we can be able to run something to see. Okay. Thank you very much. We're on the top of the hour. Any questions before we go for break? Okay, thank you. See you after break, okay? Oh, Christiana, you want to ask a question? Auntie Saka, you want to ask a question?
Yes, is there's a clarification. I just want to know something as we go on.
Go ahead.
Please, when we were doing the database, the Power BI, I understand we'll use it for modeling and for dashboard creation. With this database, are we going to design a form? Is it a form or an interface, or they will get the data just like we did for the Power BI and the other one to create models? Because
So
my knowledge
you
with data.
see, in the Power BI you were dealing with Excel data, which was very simple and easy for you, right? But the real
Yes,
world
sir.
doesn't contain Excel. In fact, the real world, there is very few Excel you actually get. The real world consists of the databases. That is why learning this is important. So towards the end of this, I will show you how the databases and how it fits in. So you are going to connect your own MariaDB to your Power BI.
Okay.
Are you getting my point?
Yes, yes. I'm now getting the idea. I now get it.
At first, you haven't learned databases. If I start databases straight away with Power BI, you will fight with me. You say, I don't know, understand this. I don't understand that. I don't understand that. Now you are learning databases. So when now Power BI connects with database, you can work with it. Is that not it?
Yes, sir. Yes, sir. I understand it.
You also learn how Power BI is integrated into R and is integrated into Python, and how your Python can access the database we are talking about and work with it.
Nice, nice, nice. Thank you very much.
See you guys 3:30. We congregate. It's recorded. So sometimes when you select something, you will just want to select. So let me give you a typical example here. Okay. So let me open. Let me see. Okay, good. So look at something, a data like this one here. Okay, search index. So I do this. Look at something which happened. When I did this, how many records has it fetched for me? How many records?
1,000.
So it's fetched for me the first
1,000.
1,000 records, right? So if you notice down here, look at it, the query it uses here. Select star from Ghana data inside search index, Ghana data inside search index limit 0,1000. Okay, that means where search index order by search index limit 0,1000. Okay, what it means is that from the first record, give me the next 1,000 records. Okay, so that is how we work with it. When you limit it, it allows you to fetch just a small number of records. Sometimes you want to preview it. You don't want to see everything. You know, the other day, if you remember, we have 384 records, 84 tables in there, that database. And when I click on the one which generates ERD, it was taking so long. So sometimes you don't want to see everything because you don't need to see everything to understand what is in the data. So you want to just have a glance, a preview, like how Power BI does for us. It just gives us a snapshot. You just need a snapshot to see the kind of data that is in there. So to do that, we use the limit. Okay, so we use the limit. So you say select, it could be select star, select column names, whatever. Yeah, that one, I think you know the selecting. Then the where condition will follow. So the normal select is there. Then you have a limit, then the number. So if you say limit 3, by default, it will start from 0. Okay. Now, what if you don't want to select everything? You want to select but start from a particular point. Okay. So you have select start from customers, limit 3, offset 3. So it will select from between 4 to 6. So it will take the first 3 records out and move on to select this, okay? So it returns only 3 records starting on the record 4. That means it has offset the first that. If you don't want that, you can do what I prefer what this guy, the one it did here. So let me just copy this guy. Select star from Ghana, okay, from search index. Search index is the table itself, right? So limit 0 to 10,000, right? 2,000. Okay, I'm coming. Let's use the e-commerce one. So let me select my customers. I have these customers here, right? How many? There are 91 of them. Okay. So I'm going to query this. And I say that select star from customers, limit 0 to 20. When I do this, it will return the first 20 records to me. The first 20. So you see customer 001 to customer 020. Okay. If I do just limit 20 like this, it will still return the first 20, assuming it's starting from beginning. But if I want to, I can say offset from the first 5. Offset the first 5. That may take away the first 5 and return the next available 20 to me. So you can do it this way, or guys, or you can do it this way, 5,20. Okay, so instead of writing the word offset, you can say 5,20. So if I have 5, if I go to, let's say 10, that means it should offset the first 10 and then give me the next 20 from the one after the 10th. Okay, so that is how we do limit. So, and all this is as a result because when data gets large and big, it creates its own problem. Big data creates its own huge, enormous problems, which you have no idea. So, guys, please, 1 minute. Hello, guys. Sorry. West Ham scored, so the people in my house were making noise. So sorry, forgive me. Footballers, are you guys here? Are people
Yes.
here with me at this lecture or they are watching football?
Yeah, yeah.
We are with you here.
Yeah, yeah.
Yes, they say Kudus has scored. So they were coming to let me know Kudus has scored.
Yes, bicycle kick.
Yeah. Anyway.
Sota is watching football.
No worry, let's teach. Let's go. We'll be fine.
Commentary.
I mean, I have a football fan here who are once my last born will come and tell you everything and jump here. So that's why I had to mute. Forgive me, guys. Primary keys in the class, foreign keys in the game. I hear you. Okay, let's move on. All right. So that's the limit aspect. Okay. So when the data side gets big, some of these things become relevant. Okay. Because you can't pull the whole data and show the person 12 million records. It will take forever. Right? Good. Beautiful. Then we have functions like min, max. I mean, as for functions, there are so many of them. Okay. There are so many functions. Min, the minimum value, the maximum value, that kind of stuff like that. So these, you can try them out. Just try them. So if I want the minimum price and stuff like that, let's try one here. I think I have my customer, my orders, right? My orders. Let me see what we have here. What do we have in the orders table? Orders dot, is there a price or something? Okay, order details. Let's go for order details. Dot unit price. Good. So select unit price from order details, right? Like this. Okay. You can select the minimum unit price. Sorry. So when I run this, it will run and give me the minimum unit price is 10.09. The max will be what? The maximum is 99.94. The average. So these are functions. They are basically functions, okay, guys? They are basically functions, okay? So nothing complicated. This is the average price, unit price, stuff like that. These are functions which come along with it. So there are so many functions. I mean, it's not everything that can be said. There are so many of them, okay? If you want to, these are functions. There are so many functions. Made, locate, all these. The sort of functions you were seeing in the Power BI, the DAX, you have a number of them here. So you can actually also do some of these. These are numeric functions, absolute, cosine, stuff like that, log. You can do all those things. You can actually write, just like the DAX you're writing in the Power BI, you can actually write much more sophisticated, complicated. So you can actually do actual programming in your database, okay? I mean, it's exciting. So for instance, let me give a practical example. And Josh is here, I'm sure. Josh, the UITS guys, your CWA, for instance, gets computed based on a small table, a small programmable function that has been written in the database itself, okay? So the procedure runs, and on that basis, your CWA comes, right? So you have very interesting things like that, which you can do with your database. Sometimes, and as you grow, as you become more experienced, you realize it's not everything. If you're a programmer, it's not everything you put in code. Sometimes some things are best put in the database because you don't need to bring the data into the memory of your machine before it does computation. Right in the database, it does the computation and bring the results. So these are some of the little tricks which you can do. I mean, there are so many of them, okay? There are so many. You need to spend some time so that you can be able to understand them. So I've looked at count, you can sum, you can do summing and all that. So you have sum functions, sum, let's look at sum all the unit prices, sum all the unit prices, right? I can write this, run, it'll give me the total of all the unit prices. You can say sum unit price times quantity, right? There's quantity. You can make it an expression. It doesn't have to be just the field. You can make it an expression. So you can have here, say, what is the minimum when unit price and quantity come together? What's the minimum you're getting, right? So you can do all these things, right? Different ways. You can put expressions in whatever. It's up to you. Okay, great, wonderful. Yeah, somebody, can you create calculated columns? Oh, yes, you can. You can create calculated columns, but they are not the kind of columns you think. They don't happen in real time. They happen on the fly as it's happening. So you can say concatenate, let's see what we have here. Okay, so we had customer, we want to put customer name and city together, right? Want to do something small around that. So concat, okay, in this case, I'm dealing with customers. Concat, what is a customer? The customer name, right? Then here I put a space. Okay, I can put a space, I can put a hyphen, whatever you want to put, I can put it in here, right? And then over here, let me put a hyphen, and then I can say add, the next one should be the city. And I can give it a column name which doesn't exist as my costs, my cost city, my cost name city. I call it something like that. And then I run. So it's created it for me. Are you with me, guys? Are you with me? The person who asked the question.
Yeah.
Nicholas, so you can do these things, okay? You can do that, right? Good. So it's up to you. You can do this and bring the other, even the other columns. You can bring customer ID here, comma, that. So bring me 2 columns, but the other column is not a real column in my table. It is calculated on the fly. Let me put a bit of space here to make it look nicer. Okay. It could even be a formula. It could be a computation, like the CW I was talking about. For instance, let me do something wild here. You can actually, and we're going to do joins very soon. So you can have, let's say, the orders, right? It was the order details, right? I can say that I want to compute the log of some of the log of the okay, select order detail ID, comma, order ID, comma, concat, not concat, let's see, okay, good. Sum, we say sum, or I can put it as an expression. Let me leave it general as an expression. All right, come on. We have example. Hold on, let me just be sure. It's my keyboard. Oh, come on, keyboard. Okay, good. So I can have an expression here and say unit price times quantity. What would this be? Unit price times quantity is what?
Order table.
What is it?
The orders table.
Yeah. You know, there's no column like that in the order details. I want to, you see, when you multiply quantity plus unit, that's what is sold, right?
Yes.
That's the amount sold, right?
Yeah.
So you can call it as amount sold. Okay, and you can run this. So this is amount sold. So you are getting me. Amount sold has been computed on the basis of a formula, not on the basis of. So you appreciate me, guys. Can you guys hear me?
Yes.
Yes, sir.
Okay, beautiful, lovely. So you can do that, right? You can do that. Okay, please practice, practice. That's the only way out. You try different things, different ways. The W3 schools is there to guide you. Java T Point is there. Tutorial Point is there. All of them have different things they can teach you. Try it. I've given you a table you can work with. You can actually set up your own database. If you have some company data there you want to work with, it's on your machine. Pump it in, try playing with the data, see what you can do, right? You've done things with Power BI, now you want to see how you can deal with your data. And these things are very important too. They're very important. Manipulating your data always is critical. Data transformation is the heart of analytics, okay? Very, very important. Because sometimes you get the data and certain things don't come the way you are. You have to create them. You have to let them be. You have to modify the data based on some of these queries. Sometimes even the data they are giving to you, like what I gave to you here. Will you, if right now you have to use this, will you need all the 99 columns? Guys, will you need all the 99 columns? I'm asking you. For analytics, I don't think you need all the 99. So you should be able to select specifically what you want based on a query. Makes life easy for you. Or create a view or something like that. We'll learn about views shortly, okay? We'll learn about views shortly. So those are your realities that you kind of get faced with. That's why learning these things are critical. They are important, okay? Good, beautiful. So we've learned that count, all these things are there. Please go over them. There are so many functions. Then we have like. Like is also another operator. So we have what we call the operators, right? We have like, equal to, greater than. Those are operators. I mean, those are normal things. You've done Python, so you should know operators by now. Parity taught you guys, right? So you should know greater than, all those things. So if I take something like this, the like basically, good. Those who are looking for the regular expression approach, one of the things you can use is use the like. Like helps us to do some things like that. So if I have a like, I can use this symbol, the percentage symbol, and then the underscore, okay? These are wildcards which I can be able to. So if I have this A percentage, that means you find values that start with A. So the A begins and any other thing after. If you do this and this, that means find values that have OR in the middle. So far as that particular column, in this case, customer name is concerned, right? If you have this, that means that this one, it finds values that start with A and are at least 2 characters in length, okay? So you have this, and then you have 1, 2, that kind of stuff. So if you want 3 characters, you put that dash dash by starting with A, right? So all these permutations are there for you. So for instance, if I have this data, what we had here, select maybe that from this, from other details, like other ID, other from other details. Hold on, let me see where I'm getting there. Where is where I've been brought in? Where other ID, like I want every other ID which has the number 8 in it. Like, okay, so percentage beginning, percentage ending, there must be 8 in it at all costs. I run. So give me only the ones that have 8 in it. Do you see that? If I want those that are beginning with 8 and anything after, I run. Now I don't have anything. Okay, those that have O and 8. Okay. So you try to use that as a basis, okay? All right. We have OM4. OM4 here. Good. O4 beginning. So let's have O4 beginning. No, we can't have, because ORD is beginning here. So these guys are in the middle. Okay. So that's how, I mean, you can work from it from different, so that's how the like thing works. Okay. So try each of them out in your query. So sit down, spend some time, try them out, okay? Try them out. Okay. Good. Then we have the wildcards, which we talked about. It selects everything. The wildcard selects everything. Can you guys hear me?
Yes.
Yes, Doc.
Okay, I thought my line was breaking. So these are, we've done the percent and underscore. We have the star also there. The star thing also there. So these are some of the things you can actually look out for. So please explore each of them and see how they also work. In is a very powerful one too. So you want to select, good. Let's have this. This is a very interesting one. So the in statement basically helps us to be able to, let me see what I can do. Okay, select star from countries, where country in. So when you say in, that means that any of these ones should be the value in there, right? So if I take this, let's go for our other details. Let's go for our other details, or let's go for our customers, right? Customer name. So I'm looking for all those who have customer name as maybe Abba and Sons. Just pick Abba and Sons, Adum Trading, and then Efie Mat, right? Let me pick a few, just a few. Abba and Sons, Adum Trading. And then I have maybe other supplies. So I'm asking him to give me things that are in this range. Let me just bring them. Okay, so I have this guy, Abba and Sons. So normally what I would do is have my in statement here. I'll close this guy. I'll do this guy too. Bring my, bring that, have that. I delete this. Okay, so I'm saying that select star from customers where any of the values is any of these guys. Okay. So when I run this, it returns to me only those ones that have the customer name being Other Supplies or Adum Trading or Abba and Sons. Okay. So that's how we deal with the in. If you say not in will bring me everything which is not it. Okay, so the opposite of it, right? Good. So that's the not in and all of that. All these help you to be able to manage your data very well. Sometimes too, so you can actually also select within something. Okay, you can select. So let's go to that one. Select star from customers where customer name in Then here. Select. Okay. Okay, select star from come in, let me see what I can do easily. Trying to look for something. It's going to get complicated though shortly. Okay, good. Okay, so these are the orders. Assuming, okay, select star from customers, where customer name in, select star, okay, where customer ID, instead of customer ID, let's use customer ID. Where customer ID in, select star from orders. Not select star, you have to, because you are looking for customer ID, it has to be in it. So select customer ID, orders, dot, it's order details, right? Okay, orders does customer ID. So I'm trying to refer to it. Okay, let me use this so that it distinguishes the customer ID in the customers from the customer ID in the orders. Select orders.customer ID from orders. Okay. Where maybe in my orders table where ship postal code is, or where ship city, the ship city is equal to Takrady, right? So I do this. When I do this and I run, it will give me this. So first of all, what it did was it will select this part. Okay, so this is giving me 84 records. If I select this guy, let me run this query. So you can do this when you are running a query. You can select it and say run selected. Okay, this actually, when I run the query that is in here, guys, look, the query that is in here, it gives me 214 records. So this is what it got for me. Okay, this is what it got for me. Then within this, I'm asking it to select where customer ID is inside this. Okay, so it will do that. The first query is run, then it looks within it and then try to pick where customer ID is like that. Okay, all right. So that is it, right? Good. Any questions before I move on? Then we have between. Between is picking two values and saying that it's in between any of them, okay? So between deals with values, okay? Right? In between any of them, okay, good. Good. All right, so you can try that one too out. The joins are very important, okay? The joins are so important. That is what the heart of relationship RDBMS relies on. So look at this table. Let's look at this table here. Okay. Now let's look at the ERD diagram of this. Look at the ERD diagram of this. Realize things are related, right? The only one which is not related is this guy I did on my own shop by the corner somewhere. So he's not linked to anybody because I didn't link it to anything. But these are the real tables. Now, remember that in Power BI, we said that when you establish the relationships, it makes it easy for you to look for data from here. Power BI basically uses a join thing to try and do that primarily, okay, because it understands the relationships. Therefore, it can pull data based on that. So I'm going to do one here. where we have, so let's go bit by bit. Okay. So I have something like this. Okay. So I want to join the tables. So I have two tables. Now, if I run this, let's look at something. Select star from, let's use the ship city being this. Star from others. Where ship city is Takrady. When we run, we are getting this 214 records. Where ship city is Takrady, we are getting 214 records. Okay, let's say where ship city is this, and shipper ID, or let's use shipper ID. Where ship city is this, okay. We just want ship city is this, and then the person, the shipper that shipped it. Shipper ID is equal to ship 002. So when we run this, it will reduce the data to 66 records, right? Good. Okay. Beautiful. Lovely. Now, having had this is good. But this thing doesn't show me which customer. It only shows me the customer ID, the customer that is associated with. Or even I want to find out, so I want to know the name of the customers that their things are being shipped from this with shipper ID 002. So to do that, I come here, I say select star from others, right? Means that I must join, look at this. Let's come here. Let's go to our entity relationship diagram. I have others. Others and shippers. They are related based on the shipper ID. Is that not it? Look at it. Guys, can you see it? I've highlighted.
Yes, we can see.
Good. So there is a relationship between the two based on that. And that is the primary foreign key thing that is leading to that relationship. Okay. Because of that, because of that, I can run my statement and say select star from others. Okay. Inner join means that if shipper ID is in the shippers table, let me go back to my object. If shipper ID is in the others table at the same time in the shippers table, then return to me something. Okay. Okay. Or okay, so this is shipper. Okay, it's the customer's name we are looking for. So it's customer. So if I look at this one is related on customer ID, right? So is the customer name we are looking for. So select star from others, inner join customers. On, then you come and say others dot customer ID is equal to customers dot customer ID, because that's where the relationship exists. Are you getting me? Hello? Then here, if anytime you do a join, it is important to be more specific. So you can say others dot, you can pick the specific things. Okay. So here, what I want, okay, let's pick specific columns. Customer, I need customers dot customer ID. I also need a customer name. So customers dot customer name. Okay. Then I do need I need the order ID. So orders dot order ID. I need the okay, so I need a ship city. So let me bring the orders just to separate. Please, it's always important to bring, because sometimes you have the same column name here, column name here. It is what is the other, it's that this thing preceding that separates them. So you have this. Then you have orders dot shaper ID. So once I do this, you can actually let it make it sorry, I'm coming. A minute. Okay, I'm coming. A minute. Oh, it used to have this. Where is this thing? Where is the beauty? Beautify SQL. So it can beautify it so that it makes it easy to follow. So you are selecting these guys from orders. You are joining it to customers. On orders.customer ID equals customers.customer ID. Where ship city is this and shipper ID is this. So when I run this now, let's look at what I get. It's giving me my customer ID, the customer name, the order ID, the ship city, and the shipper ID. Now this has happened by joining two tables. Hello. It has happened by joining two tables based on the relationship. So relationships are very, very important, right? Okay. So do you guys understand me? Yes, Christiana.
Please say the dots with the columns indicate the joint, right?
Which one? The dots. Which one?
Yeah, like customers dot customer ID. Put
Oh,
the two
no.
together.
Customers.customer ID means instead of me writing just customer ID, I'm saying that I want within the customers table, the column called customer ID. That is what that one means. Do you understand? Don't confuse the guy down here. Don't confuse the one here. You leave the one here. I'm starting from here. You see, there's a customer ID also. So let me show you the ambiguity. If I just make it customer ID and I run, it's confused. Column customer in field list is ambiguous. Why? Because there is customer ID in the orders table. At the same time, there is also customer ID in the orders table. Which one are you referring to? The system gets confused. Hello.
Yeah. So
he wants you to. Yes, so he wants you to use the table name. So you bring the table name first. So I'm looking for the customer ID in customers. Customers.customer ID. Do you understand that?
Yes, I now understand.
Okay, because in the customers table, this is a customers table, right? There's a customer ID. At the same time, in the orders table, there's a customer ID. So if we say customer ID, he doesn't know which one because you've joined the two tables now. You have joined them. So he's confused. Which one are you talking about? Is it the customer ID in the customers table or the customer's ID in the orders table? He's confused. So simply put, when you are doing this, it is better to tell us exactly which one you are referring to. I could have gone in for this guy's own. It's accepted. He won't get confused because he knows this customer ID. You are referencing the other one, not the customer's one. The customer's table one. Do you understand me? Okay, I'm going to come.
I get it.
Okay, now where your confusion is coming from is this guy. I think so. Okay, now, so at least the first part is to avoid ambiguity. That's why you have this. Now, at the same time, when you get to the inner join here, you have two tables you are joining, orders and customers, right? And you're joining them based on the customer ID. So you cannot come and say customer ID, let me delete here. It will get confused. Customer ID equals customer ID. Will it not get confused? Which one are you talking about? Are you getting me, madam? I mean, it's tautology.
Please, I'm getting you.
You need to be more specific. And there's also a reason. I'm going to go to the other joins and you know why this is very important. Even the order in which you place them is important. This is inner join, so you don't experience the problem that much. Inner join means that the ID, the customer ID in this case, should be in that orders table. At the same time, that customer ID has to be in the customers table. Okay, good. Now, let's look at something very interesting here. We have other type of joins. Inner join brings both together, right? Good. So from both tables. But we have left join. Left join. If you say left join, then the emphasis is on which one table is on the left side. That means that return to me all results that are in the other one, but must by first be in the left guy. So the reference table is the left guy. This guy here, table 1. In this case, if I'm looking at my querying statement here, which one is on the left side? Which table came first? That's on the left. Which one is it? Look at the join, please.
The other.
On the others.
Yeah.
So the others, the customer ID is on the left, while the customers, the customer ID is on the right. So in effect, you are saying that join them if the guy is here and he even doesn't have a record in the customers table, return it. Are you getting me, sister?
Please, can you repeat the last sentence again?
I'm coming. Let me leave my EI diagram and come to my list here. What I'm saying is that when you say left join, it means that, okay, hold on. So I have this statement here. Okay, pronounce. Okay, so let me do left join with this. When I do a left join with this, right, it means that whatever in the orders table, so far as this condition is satisfied and there's a customer ID there, return the corresponding in the customer ID. Whether it exists there or it doesn't exist there, show it. So when I run this, what is missing? What is missing? Something. Others dot. Yeah. What is it? Something is missing somewhere. Remember. Okay, Oniya. Good. All right, so I have this. Now I'm trying to do a left join now. So I run this. The left join returned the same thing because the customer table is so and so. It's the customer table is the main reference for the customer ID. Okay. So almost everybody in the orders table will be any customer ID in the orders table will be in the customer ID table. But look at something. Assuming I had it this way, I rather brought this guy here and then took this guy here. Okay. And then I'm doing vice versa here so that we appreciate it. Okay, let's take a look at this guy here. When I scroll down all the way, I had 40, all the way up to 40, right? Do you see that? And in this side, you have ship city, shipper ID. But if I say left join with the emphasis on the customer table, in effect, it means that, let me run this. Okay, I think this will still be because of the condition I have at the back end. Let me look for something. The condition is what is creating. I wanted to create something which you won't find. Hold on. I have to edit some. Let me edit some specific record, then we see. The customers here, customers here. Let me come to the tail end. Mhm. Also the condition. Okay, let me take the condition out. Good. Now look at it. Guys, look at it. At the tail end, it has returned to me this record. Look at this record here. Nyame Ventures. Do you see that? But there is no customer ID here. There is no this and there is no that. There is no that. Why? It's because it is using a left join and say that all the records that are in the customer side at all costs must reflect in the table. But that is whether they exist in the orders or they don't exist. Please show that for the customer side. Do you understand me? So if you look at this table we have here, we only have orders, 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 orders. There's only one customer thing here. So everything that is within the customer, he will show, but he will not show the orders because there is no corresponding record in the orders for that particular record we just did. Are you with me, guys? Similarly,
Yes,
if
sir.
I do a right join, so right join will focus more on the other guy. That means focus more on the others. If I do this, you will realize I will get exactly 830, but the other guy will not be there. Because though the other guy has no record, the system says at all costs, we should return all customer IDs in the orders table. We are not concerned about the records in the customer ID place. If it's here and it is in the customer ID, bring it. But if it's here and it's not in the customer ID, still bring it. Do you understand my point?
Redundant.
All right. Are you guys okay? Or you are still confused? Okay. Great. Wonderful. So that is left join, right join, inner join, and stuff. We have cross join is also there. You can take a look at cross join. It's like more like a union sort of thing, okay? We have self join, we have union. Union is also here. Please try them out. See how union puts two tables together, okay? So it's like it's like normal sets. It's the same thing. Okay, combines the results of two tables together as one big table. Okay, so that is how that does. Then you can do what we mean by group by. Group by means that you are supposed, you do a selection and you want to group. It's like filtering, Excel filtering. Do you guys remember filtering? Okay, if you remember filtering, so group by country, group by seat. Let's have this guy here. So like this one, blah, 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 I have this. I can say group by ship city. So he's grouped them that way by ship city. Now, normally group buys become very relevant when you try to, so there are 4 ship cities that are here. That's why he's trying to do that. But this one becomes more relevant if, let me do a left round. Okay. These ones become, group buys become very relevant when we try to use count. like the formula things, okay? Let me see. So if I'm going to do group by, normally the columns that I'm grouping is what I'm more interested in. So you have ship city. Okay, I have ship city. I'm grouping by ship city. Then I come here, count order IDs. If I run this, it's easier this way. So normally when you are going to use group by, you're trying to do something. So there are 206 orders that are coming from Accra, 213 from Kumasi, 214 from Takrady, 197 from Tamale. Okay. So normally when you do group by, the column names that you leave here normally should reflect those ones that you are trying to group by. They should be there. Normally it's best with these kind of stuff like that. Okay. Let me see if I had shipper ID. Shipper ID will not really make any huge difference. I think, let me see what I'll get out of. Okay, if I do it this way, then it's important to bring shipper ID also. If I bring shipper ID in there, now he will break it down further. So he will pick the city first, pick the shipper ID, and then do the count. Are you guys getting me? Okay, okay. Moaha.
Sir,
Okay, Doc.
I'm getting you.
Okay. I mean, should I mind? You. All right. Beautiful. Lovely. Great. Okay. So that is group by. So always note, I've told you they work better with the count and the formulas and stuff. And whatever you are grouping by can then come in. Okay. The field you group by should always be in the list of columns there. We have having these ones, I think you can also look at okay, having comes in when you have issues such that you need aggregations, okay? So having count, customer ID greater than so and so, things like that. Practice them, try them. Exists is very important. You know, sometimes, and exists even comes in, if you notice when we're trying to create the tables, exists is a general thing that is used. Let me come with this. Drop table if exists customers. So what he's saying is that if you start off and the table customer is already created, please drop it and then create the new one. Okay. So exist basically means the thing is already there and you want to. So once it checks to see it exists, then whatever you ask it to do, it does. Right. So we have exists, right? All these things are. So try them, read them. Case is meant for conditions where you want to select one from the other. It's like if then, right? If then, else, so and so. Okay. But when you use case allows you to list a number of conditions, and the last one you have else something, right? So, and I'm sure Pasty did switch. Pasty did casing or switch with you in Python. Did you not? Did you guys do that?
Yeah.
Good. Okay. So I think we've done that. Yeah, commenting is also very important. You were taught commenting. This is how we do commenting in our MySQL. You push dash, then the statement follows, okay? So this is not part of it. It's helped to explain various things about it, okay? We have various operators that you can do with plus, minus. It's the same like any programming language. Databases are actually language. They are actually quoting some program. They have some programming embedded in them, okay? That's why you can write functions, can write all manner of things. It's just like Python, okay? If you've noticed, this whole analytics thing requires you to have programming skills. If you don't have, that's why the first lecture I taught you, I had to talk about the skill set and all those things you need. They are important. If you don't understand those things, if you just watch what comes in the videos and the rest, you think analytics just happens in thin air. Please, it takes a lot of effort and work. All right, good. So I think I've covered the grounds enough so far as that is concerned. Okay. Any questions on RDBMS? Because I'm about to move on. Any questions? Okay, thank you all. Now that we are done with RDBMS, which is the traditional databases, we'll be able to cover the grounds. We'll do tutorials with Sadika on Wednesday. She asked permission to drop out, but she sent the assignment. I'm sure she'll share with you on the page. I'll ask her to do that. We now need to understand, I've been reiterating when the data gets big, when the data gets big, when the data gets big, when the data gets big. That means that when it gets big, the traditional way we do things doesn't work. Or have you not realized it? Even if it works, it doesn't work very well. You suffer. Josh, are you here?
Doc, please, I'm here.
What do you people do to the log table after some time?
The archive, please.
Yes. It gets full, right?
Yes, please.
So in KUS's database system, every single transaction ongoing in the student system is recorded. There's a log on it. So with time, the log table becomes very big. And when it happens that way, they have to deal with it. So the storage space becomes full and you have to deal with it, okay? Now, you also need to keep logs. I mean, everything happens, you have to keep logs. So sometimes you don't have a choice, but still keep logs, right? So you have to find ways of managing. So when data becomes very big, managing it, handling it, the normal ways just don't work. The normal ways just don't work. Everything starts changing. So we're going to learn a few about big data. So data getting very big and we need to deal with, whether it's in terms of records or whether it's in terms of storage space, right? Whichever one it is still big data, okay? So we want to deal with it. We need to deal with it, okay? So when it comes to the computing side, we try to use grid or cluster computing, cloud computing, parallel computing, all these tech approaches to be able to manage this kind of big data, okay? So let's look at what they are. So when we have clustered or grid computing, it's basically pooling the resources of several machines so that you can be able to perform a task. So let's say I have, look at how much, can you imagine how much data MTN is keeping a day from us? Look at everybody making a call every day. How many calls have you made today? All these things. Look at Facebook, all of them. I mean, it's enormous. And so sometimes when they need to process something, they need to invoke several machines to be able to do that little work you want. So yeah, and I always teach big data this way. Big data is premise. Oh, views. Sorry, yeah, I'll go back 1 minute. Please let me explain views. Thank you for bringing my attention to it. Let me go to views. Thank you for taking me back. They skipped. We've learned so much in just a few hours. Okay. Now, when you have the bigger table, sometimes you want to create a small peak of the data. You want to have just a small selection out of the data, but you don't want to keep it as a table. So that table, it's like a virtual table. It only comes into action when you call it. So it's not like a table which is physically stored, okay? So you can try to create, that's what we call a view. A view contains just a number of rows and columns within the actual table, but based on a particular selection statement. So let's take this one here. So we're dealing with shipper city, blah, 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 things like that, eh? Come here, I want, good. So I come here and I say, create view. Select, create view, ship Takrade. Create the view called ship Takrade. As so select, then I come here. Let me bring this guy here. I'm going to do this. Let me see. Okay, so I have this. Then I run this. What error am I getting? Okay, 1 minute. Something was wrong. Okay, no, I think it's right. It's just the way this was. Okay, yeah. So I've created this view. Now let's look at our views. If we come to the object now, we have ship Takrade. Have you seen that? Have you seen that? So now when I double click this, it will come as a table. But this table is not real. It doesn't exist. It's not a real table. It is a table that only comes in action when I double click it. But unlike these guys here, they are real tables. They have been stored on the data on the hard disk physically. But views are not stored. Okay? So for instance, let me take KUSC's databases. They may create a view of just only students in College of Humanities and Social Sciences. They may create just a view of analytics students. Okay, so you can have several views based on whatever that you think. So it gives us, it's a virtual table. It doesn't exist. It only comes into action when you run it. Okay, so that is how you create views. If you don't want to go that way, you can actually come here and say new view, right? If you want to go that way, then you put your SQL statement here for the view. Okay, good. All right. Good, beautiful. The Lord is our shepherd. We shall know. Are you okay now? So that is views for you. Okay, now that I've explained views, let me see whether there is anything about views which I mean, the rest they are basically based on the statements and all these kind of stuff. Okay, great, wonderful. Okay, let's go to the big data. So that next week we can focus on NoSQL. And then the following week we'll focus on the strategy issues, right? Then we can conclude. We'll focus on two things: the Hadoop, the environment itself. We'll do the environment itself, and then also get hands-on in terms of MongoDB as a document store NoSQL database and how you work with it. Okay, so like I said, when the data gets big and all that, resources, everything becomes, sometimes you click and it takes forever to happen. Okay, so we can use like clustered computing or grid computing, where several computers are put together to be able to achieve that. And I always teach big data with this very principle. Ashanti say prior we bakwa ebu. Okabo menye de emu. If you take just one machine to handle the whole load, it will break down. But if you have multiple machines where the job is shared across, for each to do little of the job. If you have a big farm and you need to weed it, and you have everybody doing maybe 100 meters, 100 meters, and you'll be able to finish the farm in a twinkle of an eye. But if you leave it to one person, no matter how mature he is, no matter how much muscles he has or energy he can't complete the work early because he's just one man. But when you have different computers coming together to execute the job, it makes it easy. Okay. The other thing is cloud computing. Okay. Cloud computing allows us to also pick resources as and when it's necessary. Okay. So it's more of a virtual perspective to computing. So, and it's the backbone to big data. Okay. Because in a typical cloud, you don't need to have physical machine for everything. You can even have a virtual machine. Okay. A machine can exist, a server can exist, just created on a hard disk. So on this same hard disk of mine, I can have several or 5, 6, 7, or 10 different people running their PC or their machine or their server from my small hard disk. Okay. So cloud computing allows us to be able to do that. And it allows us to be able to have different networks, different servers, all linked up, different storage linked up. So you can have a storage space here in Ghana. There's another storage space in China, but they are linked together as one storage space that can serve me. Okay. Then we also have parallel computing. Parallel computing is similar to cluster, but cluster doesn't need to execute the job at the same time. Okay. You distribute the job to them. They may do it in different ways and stuff. But in parallel computing, everything is happening at virtually the same time. Okay. So that we can achieve the results very quickly in a timely fashioned manner. Okay. So that's parallel computing. Okay. We are climbing. Now, great computing, cloud computing, parallel computing, okay, forms the backbone to big data technologies. And there are two main big data technologies, irrespective of wherever you go, whether to Amazon, AWS, you go to Azure, you go to what is it? Azure HD Insights. You go to Google, whatever it is. Google is big tables, right? They have big tables and all these kind of stuff like that. Now, everybody calls his own differently. I told you we designed them. So everybody has designed this and is calling it differently. But the heart of all of them is that there is Hadoop and there is MapReduce. At the heart of it is Hadoop and MapReduce. Okay? If you were class 1 children, I would have said, say Hadoop, then you respond. Because these two things form the backbone, the basis for processing big data. Okay, good. Now, they are basically, if you notice cloud computing, grid computing, parallel computing, they are all on the basis of distributing or distributing the storage or distributing resources. So Hadoop and MapReduce are founded based on distributed data processing platforms, okay, which basically allows us to be able to process the requests we make on a huge set of data and get results back to us, okay? So you can have things going to the framework. So Hadoop and MapReduce are not really, quote unquote, let me put it this way. Hadoop and MapReduce are really not, they are not like technologies like IoT, like AI. No, they are not like that. It's actually a framework. Okay, so you've all done, yes, like the ERD, the entity relationship diagram, it's like a typical framework, right? But where you operate within. When we talk about frameworks, you are coming to do your thesis. So if you're doing your thesis, you'll talk about conceptual framework, right? A framework brings together different things to be able to achieve a common purpose, okay? Now, Hadoop MapReduce framework is open source and it's free, okay? You can download it. I mean, I've set it up. I've set it up on my machine here. You're going to set a similar thing up on your machine, okay? But please, that is just for your consumption. In real production, what you've done on your machine will not go anywhere, okay? It's just for learning purposes, okay? But if you really want to do, I will ask you guys, and I'll do that with you. I will ask you guys to, you go to this site, Azure HD Insights. You can try Azure HD Insights. You can sign up. They will normally give you $200 to try. If you've not used yours already, they give you $200 free to try. And you can see how you can set up some of these things. But it's expensive. These things are expensive. They're expensive. Okay. Let me see what they are called. The Amazon Web Services is there. Okay. That's the AWS, they call it, right? So you can try that. I mean, there are different ways you can build things, okay? So you can look at it and then work with this also. And then Google. Yeah, Google BigQuery.
At least I won't see nothing working down.
So that's BigQuery. That's BigQuery with Google. That's BigQuery. That's Google. So you can also look at it and see how PS also work. Okay, good. All right, wonderful. But we'll use the Azure HD Insights, okay? That makes it easy for us. They know I'll give you $200 free, so you can try it out and see how it goes. But you'll get consumed in the twinkle of an eye. Okay, so Hadoop MapReduce, like I said, is a framework, okay? So this is basically the Hadoop. Hadoop has two main things that comes. So like I say, it's a framework that allows us to store and process large data sets in para and distributed fashion. Two main things happen in a Hadoop. One is the storage part. The other is the processing of the of data that you have already stored, okay, in case you need to process it. So there is a storage part, and then there is the processing part. Very important. Okay, good. Now, how does that happen? So the storage part is what it gets stored on what we call the HDFS. And HDFS simply means what? Hadoop file system, right? HDFS simply means Hadoop file system, okay? Now, the Hadoop file system basically has two main components. It has what we call the name nodes and the data nodes. If you've had this work before or anything, we have what we call the master and the slaves, the parent and the child, okay? So the master and the slaves, okay? So normally what it does is that the name node normally will contain the metadata about the data you are trying to store. Where is it stored? In the bigger place that you stored it. What are the few details about it in that place? All that is stored in the name node or in the master. Then where the actual data is stored, whose metadata? Metadata means the skeletal information about the data, right? That's where it's stored. Where is it? How is it? Blah, 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 things like that, okay? The data itself is stored in the data nodes, okay? That is where the actual data is stored. So when you make a request to an HDFS, the first place it goes to is the name node. And from the name node, it goes to the cluster and finds out from the cluster which of these is this information you are looking for written to. So it doesn't write information particularly based on a very defined structure. No. It stores it as if they are objects. An object is a collection, right? A collection. You, a human being, you are an object. But in you is your kidneys, is so many different things, right? So when we're storing things on the HDFS, we store them as if they are big time objects. Fine. We are not interested in what is in that data itself. No. It picks the data. It's all it cares about is stored. Unlike the RDBMS approach, where you realize that the relationship and all these things need to be kept. You need to understand them to be able to access them. This one doesn't work that way. Okay. Any questions, please? Any questions? Okay. So the HDFS basically creates an abstraction level over where resources can be seen and being looked at as a single unit, but in a distributed fashion. So this is a typical HDFS diagrammatically how it stores. Okay. So you are trying to store 512 meg of data, which is big. Okay. Now, in a typical HDFS, when it comes, the master or the name node will try to break it so that it sends it in chunks. You take this, you data node take this data node take that, you take that. He'll break it maybe 512 to break it into 128, 128, 128, 4 of them. Then it sends it to the various for storage. But as it sends it, it keeps where they are stored. It doesn't keep the information itself, the relationship and all those things in there. It doesn't care. It doesn't even care what kind of data is stored. All that it cares about is I've stored the data, broken down into smaller chunks. And so if you remember when we were doing the Power BI, I made mention of something. When you are dealing with normal relational databases, easily, extract, transform, and load will work. But when you deal with big data, extract, transform, and load will not work. Actually, you load first. Your idea is to store. You load first before you extract and try to transform. So you load first. Load means you are actually trying to store it or put it in a certain place. That's it. Finish. That's your goal. Store it because it's coming big. You are not interested in the details. You just want to store. Pang. You are off. So normally in that one, we say ETL doesn't occur. Rather the other way that LET rather occurs. Load, extract, and then you try to do transformation. Okay. So that's why we say that Hadoop has a distributed file system. Okay, try to store them in chunks like that. Okay, good. And as you need more, you put up more servers, and it keep on working. So far as the master is there, the master can coordinate where everything has gone. The things have been gone, the chunks have been dumped. Okay, so and this is because, like I said, when the data is very big. Now, the next thing, when you have unstructured data, it is important that it's very difficult to have a formal thing related to how unstructured data is stored. That is why in HDFS, it doesn't care about the way you've organized your data. That is none of its headache. It doesn't care about that. All it cares about is that he's dumping the data where it needs to be dumped. And that's very important to it. He just picks the data, dumps it where it needs to be dumped. You are looking for a place to sleep. I've given you a place to sleep. As to whether the bed that you got is orthopedic or what, that is not relevant. You got somewhere to sleep. That's where big data perspective with the HDFS, the Hadoop approach comes from, okay? All right. Now that we've been able to store our data, despite how big it is. Yes, Yao, go ahead.
So in that case, I don't know if I'm leading, but in that case, how does it check for integrity of the data? Doesn't it care with integrity?
Let me go a bit up so you see something. No SQLs, non-relational database use what we call base. What they basically care about is the first guy. The data is always available.
Oh, okay.
They are not concerned about the integrity of the data and all those things. You understand my point? They don't work based on relationship. Nothing like that. There is nothing like this is related to this, that is related. They don't care. It is none of their headache.
Okay.
Right? That is not what it's not guided by that.
Oh, okay.
But unlike the other
Because-
guy, yeah, what's up?
Because in my head, I'm thinking of the views of big data, whereby we talk about the veracity, whereby we need to make sure that the data is a little bit credible. So if this doesn't really care of the consistency, I'm thinking about it in my head.
So you are thinking consistency wrongly. Consistency here, it's about the data being related in one way or the other,
Okay.
right? You are thinking about having correct data. Okay.
Yeah.
I spoke English, but my tenses were wrong. It doesn't care about your tenses. All it cares about is you speaking.
Oh, okay. Got you.
It is you, the person who is come to work with the data, that needs to care about garbage out. Hello.
Makes sense.
So that aspect is not left at the point of storage. They don't care about that at that point. It is you who is collecting the data that needs to make sure that you put in structures to safeguard that what is coming is good or bad. Do you understand me? At the point of they storing the data, they don't care about those things. Hello?
Yes, sir. Makes sense.
So if I'm programming, it's in my programming perspective that I'll put some of these constraints. I will not wait for it when it gets dumped. Before, when it gets dumped, as it comes, I work with it. That is why you, as the analyst, go through a lot in terms of data transformation when it gets to you. Are you getting me?
Yes, sir.
Gathering good data. And that is why sometimes people say, this morning I was talking with somebody, and for me, people may say, but I like anybody who would take us along the path where our country is more digitized. Things are, you see, Charlie, if you say Ghana and Nigeria, me who the air you could do so. See the badrio, see the top. How can you even travel when you are traveling? How many of you when you travel? I don't know where this concept comes. Who took also $100? Hey. Have you heard that?
Every single time. It's a
Do you need
$100 and
I don't know $100 when your whole ATM is with you. For your whole bank account is with you. Why do you want to change dollars? And ask the people, even online, when you use your card, it's cheaper. The rate is cheaper than when you go and change. Hey, I wonder how.
People, they fear exchange rates and charges.
It's silly. Because in the developed world, nobody thinks about exchange rate. We don't think. We live. I mean, we are so worried about it. People are hoarding dollars in their rooms. You saw the whole Sicilian issues. And sometimes I just sit down. So it's like that, right? It's the notion anyway. God help us. Africans need, what African needs is a mindset change, not money and resources. We have too much resources. Our minds are so bad that we don't even know where we are going with it. No, somebody has packed dollars into a bag. I'm changing dollars to cedi. Hey, we really have a problem. God help us. I don't remember the last time I traveled. When I travel, the biggest amount of dollars I've ever picked is about $1,000. And every time I go, I come back with all the money to come and put back in the bank. In fact, it's just sitting there. My whole ATM is with me. All my whole bank account is with me when I'm moving. Why will I need that? And you travel and people want to pick dollars to pay for something. Sometimes when you travel, those of you who try it, when you go to the advanced countries, you try and people are they look at you. Where is this guy coming from? Oh, he's an African. No wonder. Oh, yeah. Master, it's true. I remember going to buy a laptop that was 2016, right? I went to the US. I bought a laptop. I was excited. Me call my sister Misika. I've changed my money. I bought a laptop. That time, a very, very, I mean, I think I've forgotten what laptop it was. I like expensive laptops. I like large resources. I like big screens. And I think we're around $1,100 to $1,200. Will you believe the store came to a standstill? The black man has arrived. He has removed $1,200 to buy a laptop. The guy, when I gave the money to him, he counts it, then he raised it to the sky and check. It was $100 bills. You know how Ghanaians do it. Pick it, look. He picked it, look. Then when he was done, he called his supervisor. His supervisor also came to count. I was like, gee, could have seen in Abatown. What? Anyway, guys, let's think big data. And we still want to go back to Gotchesbeck issues. Anyway, let's move on. MapReduce. Okay, so we've dealt with the storage aspect. That is the first part of the whole Hadoop framework. The first part is the AD perspective, okay? The storage part. Okay? Now we're going to the processing. That's where you are asking me a bit. Where you are pushing me is towards the processing. So the data is big, it's large, but we still need to process the data for some results. How do we work with it? So then it uses what we call the parallel processing approach. And that's what MapReduce come in, okay? So the data that came, whatever thing you want to process, it just picks the ones that you need, which are relevant to the data nodes are stored. It picks them, then it sends them to the machines that, the resources that processes. Then they pick it and then work on it. Simultaneously, it breaks it into chunks when it's trying to work, into nodes. We call them nodes, basically. It breaks them into nodes, and the nodes will work. When they are done, they put their results together and come and bring it. Let me give you a very typical example. Okay, so I have some data. I have, let's say, I want to add, my son is doing something in mathematics, very interesting. They are learning how to divide. And I like the way the teacher has gone. I like the formulas, the way they are doing it. So he picks, let's say, 25 over 15. Okay, he sees 5 can go in. So he does 25, 25 over 15 will finish immediately. let's look at 30 over 10. So you do 30 divided by 2. 10 divided by 2. The answer he gets, okay, he looks at it. That's giving me 15 over 5, right? Then he looks at 15 and 5. 5 can go in, then you do 15 over 5, divide by 5. 5 divided by 5. So he gets 3 over 1, right? Which is 3. So the same thing, but he's doing it in smaller chunks, right? Instead of going to say that I want to divide 30 over 10. He wants to go 5, he wants to go 2 and go 5. Okay, it's the same thing, the same results being achieved, but it's being done in smaller quantities before we arrive. So that's the principle of the whole map reduce perspective. So once the data comes in, and that is where it is. So who asked the question? Yeah, you were the one, right? So is the program you write at the map reduce perspective that determines your consistency. Hello? Are you with me? Can you guys hear
Yes,
me?
sir.
Good. So, and we're
Yes,
going to
we
look at a
see.
framework to write these map reduce things and stuff, right? It's coding, it's actually programming. So it is that thing that you do that you use as a basis to get there, right? So if you want to really ensure that good results come, then it's what you decide to do at that point that matters. Okay? It is not the storing that matters. You go out for the storage point, you have overcome it. But now how you process, also you want to break it down, but it's the programming, the code you write at that point that determines things. 1 minute, please, guys. Okay, guys, sorry. I was talking to Pasty Small. Okay, let's move on. So that is map reduce for you. Oh, we are almost at the top of the hour. Okay. Let me see where. Okay, let me leave it here. When we come back next week, I'll start from here, okay? All right, so I'll share. We are just left with about 16 slides, right? 16 slides, and then we should be fine. I'll share this. I'll share the slides with you, okay? And then share this thing with you. Okay. All right. So I leave you at map reduce. We'll continue. Okay. I'll leave you at mark reduced. Are you okay? Are you guys okay? Any questions
Yes,
before I move?
Yes, sir, we are okay. Thank you.
Okay, so next week we will do that. And then I think we will do, let me see, big data ecosystem. Hold on. See, next week. So we'll go into the big data itself. Let me see what we can do. We'll do the NoSQL and then we'll go into the big data itself, the ecosystem itself, how you build the whole framework, okay? The framework is bigger than you think. Okay, so we'll go into the ecosystem. So this is the ecosystem. So you'll see how the Hadoop ecosystem really works, right? We'll see how that works. We'll see how the various. So this is map reduce. So the Hadoop thing is bigger than just the one. This is where this ATFS, this map reduce. We look at different things. You heard of Spark. If you've heard of Spark, you've heard of Uzi, all of those things, Pig, Hive, all that. So we'll go through them, okay? All right. God be with you till we meet next week. Have a nice week. Sadika will meet you guys. She will share the assignment she has for you this week. All right. Any questions before we part off?
Doc, please, not a question, but just a reminder that our videos, please. So that you can send
Hold on. Before even you go, let me just put them in there. Hold on. Okay, so I'll leave it on when it's done. Do you know what? Let me share the whole folder with you guys, okay? So that whatever comes into the folder, you can pick them. Okay, so I'm sharing. It will take, okay, it's going very fast. 7 minutes. That's good. That's a good one. Saka, please speak.
Is that yesterday and then today's one?
No, today I've not ended. When I end that, it will generate. It's yesterday's one that is uploading. So just about 4 minutes. Let me put it. I'll put the link once. Yes, we will do in person next week. But Accra will join us virtual, okay? Then when we do it vice versa too. This time I will want to do that aspect. Okay. All right. I'm sharing the link with you in your page so that once it gets done, you can just pick it. I'm putting it into a whole folder, so you can always open the folder and pick the things that you want, okay? Great, wonderful. 3 minutes left and you should be able to pick. Achu, are you okay now?
Yes, Doc.
All right. Okay, I wish you all a nice week. Enjoy yourself, have fun, be good boys and girls, and men and women. Bye.
Thank you,
My
Doc.
dog.
I'll put, you know what? Let me do this right now. I'm putting the slides in that same folder, okay? Let me put a slide in that
Okay,
same
sir.
folder. I guess that will greatly reduce all this. I'm putting here and so everything will always be in that folder for you, okay? So
Thank you.
that we can have our peace. Let me see. Oh, come on. Okay, so I've dropped that one too. So I'm sure when the other is queued, so when the other finishes, the other is left with
No.
about less than a minute. Yes, please.
I just tested the link. It took me to the big
It's a
data
folder.
videos for.
It's a folder.
Okay. Not the
The
parents
folder
folder.
is empty now, right?
Yes.
And it's empty because it's still uploading.
Okay. I
Let me see. Oh, it's almost
initially thought
done.
you were sharing the fundamentals.
One
of big
minute. Hold
data.
on. Hold on. Hold on. It's almost done actually. So that you can check to see whether you are seeing something. Check now. Just refresh. Has it
Yes,
come?
but I can see. Yes, sir.
Both of them are in the PowerPoint and the first video. Okay. Let me rename the video so that you have it as a session. This is 18th May 2024. So I've renamed it to 18th May 2024 so that I'll use the dates to do that. All right. Yamin come home, mama, bye. Enjoy the week, okay? And practice. Practice, so guys. Practice. Practice. Bye.
That's it.
Bye, dog.